Hello friends, welcome to a C# Intermediate to Advanced tutorial. Now we will start learning threading support in C#, and from this video onwards we will be spending some time on C# threading, and that requires some 5 to 6 subseries of subseries. So here we are starting the first series on threading. We divide this series 1 as 4 videos. First we will learn about threading, then we will see what is meant by single threaded UI. After that we will see how to start a thread, then we will see how you can join a thread so that one thread will wait for other thread to finish. Alright, now we will go ahead with the introduction to C# threading. We know Windows is a multitasking OS, means it can run more than one process. So in this C# advanced tutorial, by this time I hope you know what is a process and what's a program. A file which is in the disk is a program, and when it is loaded into memory and when OS is executing the instruction set, then we call that program as a process. Likewise, Windows is a multitasking OS and it can run multiple processes. That means it loads multiple processes into the memory and start executing the instruction set by doing the context switching. So if there are CPU will try to execute the instruction set of all process in a parallel way. Parallel way in the sense that we will learn about time slicing when you in this video itself. At that time you will come to know, but for end user perspective it will look like the operating system is running multiple process. Since it is running multiple process, we can say it is a multitasking. A good example for multitasking is you can do a file search, and in the meantime you can type something in the notepad. So a file search will run a separate process, OS will run a separate process, and when you are typing something in the notepad process will respond to your keystroke and displays the character which you hit in the keyboard and displays that in the notepad. An executable, for example application, Windows service, all are executable, is called a process. A thread is a parallel executing task within a process. So we are talking about process, right? Windows operating system can span multiple process. A process can span multiple thread. So a thread is a parallel executing task within a process. So just like how it looks to you that multiple process running in a multiple process running in parallel, the same way it looks threads also running in parallel. That means based on time slicing, instruction set will be executed on a process and at the same time on a thread which is spanned by a process. C# provide threading support via system.threading namespace. A process can span one or more thread. That means a parallel execution coding unit. A thread can also run in parallel just like a process. Running in parallel is a simulation. OS tries to run the process in parallel, and if it is not possible, performs time slicing. So you can think it this way. Let's say you have a laptop, and the laptop has 4 CPUs, and 4 CPU means there are 4 CPU that works simultaneously and tries to execute the instruction set. But a OS can have multiple processes that can run in parallel. So the process definitely more than 4. So just by looking at the Windows service itself, you can come to know that there will be definitely more than 4 service. That means more than 4 process. But there are only 4 CPU in our example. So this means it's not possible for 4 CPU to run all the process in parallel. So what happens? The CPU will execute more than one process based on time slicing. Let us say OS is running 2 processes, P1 and another process is P2. We will also consider P1 has spanned 2 threads, T1 and T2. So the picture beside explains time slicing. So let's say we have a process P1. Process P1 have some instruction sets. Then we will also consider there is one more process P2. P2 also has some instruction set. We will also consider P1 has 2 threads, right? There is some more instruction set here. So let's say this is a thread T1 and the second one is a thread T2, and the process T2 contains only one thread T1. So as already told, in a system there may not be multiple CPU. Multiple means let's say if there are 400 processes, it's not possible to have 400 CPU. There will be 8 CPU core, or so there will be a limitation on number of CPU. So for our example, let us take we have only one CPU, central processing unit, that performs the execution of an instruction set. So what happens? Thread T1, right? We can say in a second, let's divide the second into 5 slots. So CPU is executing the instruction sets continuously. So what happens? It performs a time slicing. Time slicing in the sense for process P1, let's assume it performs a time slice of 3 out of 5 seconds. And here process P2, it provides a time slice of 2 out of 5, let's say microsecond or even nanosecond we can say, because CPU instruction set execution is quite faster. So just for example, I took it as a microsecond. So 3 out of 5 microsecond is given to process P1 and 2 out of 5 second is given to process 2 that spans one thread. So what happens here? For process P1 it is giving 3 seconds, right? So we can assume that 2 out of 5 is given for T1 and 1 out of 5 is given for T2. So what happens? A context switching takes place. Let's say it executes some instruction set, for example 3 instruction set. Then let's say the time is elapsed, it performs a context switch, so it goes to process 1. In process 1 3 seconds is allocated, right? So it may execute 2 instruction set on thread T1, then 1 instruction set on thread T2. So for us it looks like all are running in parallel, but if you see in case of one CPU, it definitely execute the instruction set one by one on each translated code. So since this is in nanosecond, it look like all processes are running in parallel because of this time slicing mechanism. So here we are talking about a single process, right? P1 and P2, two different process, and slicing is managed by, or parallel running task is managed by the OS. So if it is a Windows 10 or Windows Server 2013, 14, whatever, so OS itself knows how to do the time slicing. But let's say this is a user program P1, and here thread we can manage to create or span two different thread or two parallel execution. So in that case, since we say thread T1 and T1 and T2 we want to execute in parallel, so when CPU gets a time slot for this specific process, it will further divide that time slot to execute these two parallel execution code, or to execute these two thread T1 and T2. It make use of it, in the sense the OS will make use of 3 out of 5 microsecond, which is the time slicing allocated for this specific process by the OS, right? So process will run in parallel, and P1 P2 will run in parallel, and within P1, if you see, since it has two thread, the thread also will get a chance to run in parallel. That means based on the time slicing. So that's what here we are talking about time. Thread can save time, and how? So the execution speed, if you see, if here within a given microsecond 1 2 3 4 5, if 6 instruction sets are executed, even if the OS is not a multitasking OS, but the CPU capacity is same, and if we execute 7 instruction sets in a single process, the performance will be same. So whatever time it takes to execute one instruction set, the same time will be taken even if all instruction set present in a single process. So then how threading will save time? So let's look at that with one more example. Let's say we have two works. Let's consider a process that has to perform two works. The first work is connect to a specific IP address, and on the target machine pick file starting with a specific name, so IP address, then on a shared location or at a specific folder location in the target system, check for a specific file name, then transfer the file content from the network to the current machine. And let's state this operation takes 15 seconds. Then work 2 is completely independent of work 1. So work 2 is reading 100 greeting message from the database, then send email via Exchange server to so 100 greeting message from the database and 100 recipient letter state, and send the greeting message to the recipient. So both are two different tasks. Let's assume like that. Now let's see how threading save time. So let's state that there are two processes. Process 1 is doing the same task, and there is one more process which is also doing the same tasks. That means there are two tasks, right? So what process 1 is doing, it is using single thread, let's say main thread. it is executing the first task of connecting to the IP and transferring the file content, and it took 15 seconds. And after finishing this, a completely independent task of a second one is initiated, and it reads the database, gets 100 email address, then 100 different greeting message, and a message is sent to the concerned people. So this is 20 seconds. So instruction set execution won't differ in time based on the CPU performance. CPU, we cannot change the CPU, and if a CPU takes, let's say the CPU performance is specified in terms of heads, how many instruction set cycle it can execute, and that we cannot change. So if it takes some nanosecond to execute 5 instruction set, same nanosecond will take place when you keep these instruction set in multiple threads, right? So here, but what happens is, this is a completely independent task, and after process 1 or after work 1 is completed, work 2 is taking place. But here, if you see what happens, the instruction set will get executed, and in the meantime the second one also will get executed. After that, when time permits, it will execute this, then this will execute this instruction set also. So what happens if 20 seconds, and so the CPU will allocate time, right, for process P1 and P2. So if it takes 20 seconds and if it takes 15 seconds, and since both are simulated to execute in parallel, and there will be a context switching also in between, so it may take 20 plus overhead of switching, so 22 or like that. So there are some other case also. Let's say there is a Windows based application and user is initiating the task, and one task is executing, and in the meantime user can type something, let's state like that. So this also will save time. Why? Because the task that is running may have 10 seconds, and user no need to wait for that 10 seconds if these two are executing in sequential. So user has to wait for this 10 seconds to complete, then they can start typing. So if these two are running in parallel based on the time slicing, the background task, it will go as a background task, and in the meantime user can type something. So they need to wait for this 10 seconds. They can utilize that 10 seconds. So this way, when we use threading, it may save some amount of time, especially when there is a user intervention. So if some task, if it takes more time, let's say 20 or 25 seconds, and user no need to wait, they can perform filling the other task. If it is a form based UI, let's say it's a Windows form, they clicked some button and it initiated a task, and if it is in a single thread, other piece of code won't run on the same process, so user is blocked for this 20 seconds. But if it is running in parallel, because of time slicing and context switching between the thread, user can type something and they can see whatever action they perform appearing on the UI control, and in the meantime when user is doing something, the background task also will go on and get completed. So that way it will increase the performance of the application. So there is no demo here. Thank you for watching. Bye.